All right, ladies and gentlemen, lesson 7.1. Chapter 7, we're going to be discussing graphing and throughout the chapter. And so lesson 7.1, we're going to begin with some of the review topics to graphing, specifically what are ordered pairs, and then graphing on the coordinate plane. We're going to identify parts of the coordinate plane. We're going to use ordered pairs to find locations and do some graphing on it. And then we are going to, the new part, or new items that you're going to need to be able to do are to find horizontal and vertical distance between points on a graph. And there's little formulas to help you with that. So we'll get to that at the end of this little section. So first of all, the coordinate plane. We call it the Cartesian coordinate plane. That is the technical name for our graphing system. It was developed by a gentleman named René Descartes, who was a French mathematician. He was the one, and based on his last name, we take the idea of Cartesian out of his last name. The Cartesian coordinate plane is defined by the intersection of two number lines, the x-axis, which is horizontal, the y-axis, which is vertical. And again, they're just simply number lines. Where they intersect, we call the origin, O-R-I-G-I-N, which its ordered pair, which would be 0, 0, that would be its location. Now you'll notice these number lines here break the coordinate plane into 4 parts, which we call those quadrants. And beginning in the upper right-hand quadrant, we have quadrant number 1. Okay, I'm using I. This is a Roman numeral 1. And going counterclockwise, we number the remaining quadrants. So quadrant number 2, I in Roman numerals, is in the upper left-hand corner, and we're going counterclockwise. Lower left-hand is quadrant number 3. And quadrant number 4 is in the lower right-hand corner. And yes, you need to be able to identify the quadrants. Okay. So again, x-axis horizontal, y-axis vertical. Quadrant 1 in the upper right going counterclockwise around quadrant 2, quadrant 3, quadrant 4. Ordered pairs. An ordered pair is a pair of numbers, which we go x then y. That is alphabetical, which we use to locate a point on the Cartesian coordinate plane. So this pair of numbers, x, y, defines a location, defines a point. And in order to use those locations, x, again, x alphabetical, x comes first. That tells us right for positive numbers or left for negative numbers. So we will begin by going right or left. Then we will use the y coordinate. If it's a positive number, we will go up. If it's a negative number, we will go down. So we're going to take some time. First, we're going to plot 4 points. And before we move on, just for practice and review, so we're going to plot point A, which has an ordered pair of 2, 3. And you'll notice I've indicated here, because it's a positive 2, we will move to the right 2 units. From there, a positive 3 tells us to move up 3 units. So I will start at the origin. Again, my positive 2, I move to the right 2 units. My positive 3, I move up 3 units, and A will be placed there at 2, 3. And I will go ahead and label it point A. And you'll notice here we are located in quadrant number 1. Alright, B is a negative 3. Actually, here, let me put my point there at the origin. Negative 3, well, my first number tells me to go left or right. Because it's a negative, I'm going to the left 3 units. And then from there, a positive 2 tells me positive, move up 2 places. So point B, you'll notice, is sitting in quadrant number 2. C, negative 5 for my x-coordinate tells me to move to the left 5 places. And a negative 1 for my y tells me to move down 1 unit. And so this will be my point C, which happens to be in quadrant number 3. And D, go ahead and move it out to the origin. You'll notice 4.5. On my graph, though, you'll notice I labeled by ones, okay? Which means I'm going to have to do a little bit of approximation because my labeling here does not go by halves. Now it could, and there may be times where you would choose to go 1/2, 1, 1.5, 2, 2.5, 3, and so on, depending on how precise you need to get. In this case, though, going by ones really works. But 4.5, that means I'm going to go to the right 4 and then a half. So I'm going to have to approximate where a half is going right and left. So it's about in the middle, right? About halfway between 4 and 5. And then -2 tells me to go down 2. And so I will be placing my ordered pair, my point for D, down here in quadrant number 4. But again, I had to do a little bit of approximation, and that's okay. There may be times that your scale does not have halves or things like that. So you may have to approximate. Now we're also going to talk about, let me get rid of these. I should have erased those earlier, but that's okay because I'll be putting them on. We're going to find the distance between points on the graph. So here, let me flip to the next slide real quick. So I have point A up here at 4, 3. I have B down here at -3, -5. And I am going to find the horizontal distance between them. So that's the question here, is how far apart are they horizontally, right and left? Now, if I have a graph like I have here, I could count them 1, 2, 3, 4, 5, 6, 7 units apart. But let's pretend for a second that we don't have the graph. In order to do it without the graph, I have to subtract, you'll notice my little formula here, my second x value, that's what x sub 2 means, the second x value, minus the first x value. Now we're going to subtract the x values because if you recall, the x coordinates are the things that determine right and left. So if I want to figure out how far apart A and B are horizontally, I will subtract their x coordinates. Now remember, here we go, we have x sub 1, my first x value, x sub 2, my second x value, and this tells me to take my second x value, -3, subtract my first x value, which is 4, and then I'm going to take the absolute value of these, and I'm going to show you here why, because this one is going to be important. -3 minus 4 is -7. Okay. The absolute value of -7 is 7. Okay, now why do we take the absolute value? Well, distance between 2 points is always a positive. Okay, this distance here, 1, 2, 3, 4, 5, 6, 7 units. Well, distance is always a positive 7 units. We don't care that the negative is just because of the direction in which we subtracted. It's still 7 units apart. So that's where the absolute value part comes into it. We don't care that it's a negative. We just want the total distance. So we're now going to find the vertical distance between A and B, and you'll notice vertical distance here, I subtract the y coordinates. And again, y, WHY. Why am I subtracting the y coordinates? Well, it's because the y coordinates, the second ones here, determine up and down. Now, so what we're doing here, if I go back to, we're trying to figure out how far is it vertically between these 2 points. And again, if I have a graph, I could count it out. 1, 2, 3, 4, 5, 6, 7, 8 units. Okay, there's 8 units from up here down to here. But let's prove it using our formula. Let's pretend that we don't have the graph. So this is my first y coordinate. This is my second y coordinate, y sub 2. And so I am told take your second y coordinate, -5, and subtract your first y coordinate, which is 3, and take their absolute value. Well, -5 minus 3 is -8. But I don't want negative distance, I just want distance. So the absolute value of -8 is 8. They are 8 units apart vertically. Okay, again, you'll notice from here to here, 8 units apart. Now watch one other thing though. What would have happened if I did these the other way around? What would have happened if I would have let this be y1 and this be y2? What would have happened? Okay, so if this is y2, 3 minus, okay, because I'm subtracting, my y1 then would be a -5. Watch this. Okay. This is, you also have to go back to things you know before. Minus a negative is plus. So this becomes 3 plus 5, which is positive 8, the absolute value of positive 8 is 8. And either way, you'll notice I ended up with 8 units, okay, vertically. So these 2 points, if I go back a couple slides, they were 7 units apart horizontally, and they are 8 units apart vertically. And we do so by subtracting the x-coordinates for horizontal, because the x-coordinates determine our horizontal moving on the coordinate plane. And then they are 8 units apart vertically, because, and again, subtracting the y-coordinates, because the y-coordinates are the things that determine our up and down movements. So that gets us to the end. We are going to, in that particular case, go ahead and get to our practice. And so any questions, please come and see me. Otherwise, go ahead and work on your assignment.